So today it's solid 6.0, not 6.1, because we're really doing a little bit of review, 8th grade math. So November 10th, Novembre 10, sí, 2021. So our objective is really going to be multiplying and dividing we call monomials. Okay, mono means one, like mono e mono, man on man, one. Mono means one, and nomial means number. Mono, one, nomial means number. So like, all together that's one number. There's no plus or minuses. There's no plus or minuses, right? That's one. That's one. There's no plus or minuses. That makes sense? That's just one. I mean, so it's one thing, but it's a number. We don't know what x is. It's a number. We don't know what x is or y is, but they're numbers, okay? So, express. And this is a review. Yeah.
How do you spell
monomial? monomials. Thank you, Tay. So, express. Expand it for me. So this is the same thing as 2 times 2 times 2 times 2, okay? Times x times x times x times y, right?
Why would we ever write this down?
Good Lord, would you teach? Because that's exactly what I was going to say. Like, you beat me to the punch like that. So like Michael said, why would you ever write it like this?
To annoy little children.
Right, so we don't write like this. What we're going to write it as is as 16. We're going to write it as 16x3y2, right? It means this. Well, we don't want to write that. That's annoying. Thank you. Thank you. So a better way to write it really is just 16x3y2. Everybody good with Michael? That would be annoying, right? But it shows what's going on, right, Michael?
Yeah.
Now, in example 2, same thing. Let's fix it. Now, so when I'm going to multiply, these are whole numbers. 2 times 4 is 8. Now, this is really x times x times x times x times x. How many x's would I have?
A lot.
How many? I have 4 here and 1 there. How many? So I add exponents. Those are the little numbers. So I'm going to have an x to the 5th because this is 4 of them with 1 more. How about the y's? How many y's should I have? Y to the? Yeah. How many z's do I have? Yep, that's it. There's your answer. Thumbs up. Hopefully you did this in 8th grade. Mr. Bard said, yeah, I think you did it in 8th grade, but you didn't do this in 8th grade?
No.
Okay. Bailey, question.
Up in the first thing, you got a 16 for the 2 to the 4th power, but on the bottom it says 2 to the 4th power and you got 8. So I'm like kind of confused there. It says 2x.
Oh, great question. 2 times 2 times 2 times 2, or 2 times 4. See it again? 2 times 2 times 2 times 2, or 2 times 4. See, 2 to the 4th power is not 2 times 8. It's not 2 times 8. It really is 2 times 2 times 2 times 2. This is just 2 times 4. Great question. Okay, how about example 3? Or example 2. Now, there's 2 ways to do example 2. You could do it the long way. Michael, go hold your tongue, Michael, for just a second. Give me a chance to steal your thunder. Okay? Okay. Don't say it, Michael. Don't say it. Can I say it?
Sure.
Now, you really don't want to do it this way because this is the long way to do it, okay? Instead, what I notice is x3, x3, x3. So there's 3 3's, aren't there? Y5, Y5, Y5. So there's 3 5. So if we have an exponent to an exponent, we what's the rule? Exponent to an exponent? What do we do? We're going to multiply our x's. You guys never learned this last year, huh? Wow. Okay, well, there we go, right? So we're going to multiply exponents. So I do know 3 times 3 times 3, so I've got a 3. Okay, now this may confuse you, but I don't want to. This is 3 to the third, which is 27. You okay with that? Whole numbers? 3 to the third is 3 times 3 times 3. X to the 9th. Y to the 15th. Isn't that easier than doing it and writing it out three times? This will work. You can write it 1, 2, 3 times. 3 times 3 times 3. X3, X3, X3. Y5, Y5, Y5. Or just multiply exponents. Okay? Now example 4, what I'm going to do first, because I remember order of operations. You guys remember order of operations?
Yeah.
We're going to do exponents per, we're going to do this before multiply. So exponents, we're going to do this first. Order of operations, we do this first. So let me highlight that. Okay, open your brain real wide, and I'm going to ignore this for a second. Okay, I'm going to write, everybody watching? 9. Where'd I get the 9 from?
3 times 3.
3 squared, 9. X to the 8th, y to the 2nd. Think about that before I show the rest. Got me on the 9, 3 squared. That's x4, x4. That's y times y. Okay, you all right with that? I'm not done. Now, whole number, I'm multiplying invisible times, right? Invisible times. 4 times 9 is 36. X9, x to the 9th power. Where did I get the 9th power from? There's one right here, isn't there? There's an invisible 1 and the y squared. All right. Now,
Why does the y stay the same?
great question. Here it is, right? I mean, Mars, here it is, and you're okay with it being here, right?
Yeah.
Is there anything to multiply it with that is another y?
Oh.
No other y, right? Now, this...
Where does that third power go on the 4x?
Yeah, that's
Yeah,
what
that's
I'm
mine.
wondering too.
Disappeared.
4x.
Yeah. 4x.
Right here?
Yeah.
Oh, I got 9 of them. Where'd the 9th one come from? I got 8 here. Where'd the 9th one come from?
Oh,
No,
invisible.
there's a 1 there.
So the third power, not 1. 3 of them?
Oh, my goodness.
Yeah, there's 3.
Okay, because I made a mistake. Thank you. Who said that? Okay, good job, Mars. That was my mistake.
I said Maisie.
Maisie, good job, Maisie. That was my mistake. Michael, thank you. Okay, now. Michael, hold your tongue for a second, okay? Because you're going to say it. Okay. Right? I mean, would you really do it this way?
No.
No, and what you would do then is, let's see, this x cancels with this x, right? This x cancels with this x, cancels this x. You're left with 3 left over, right? What would be an easier way to do it? What's the easier way to do it? What's 7 minus 4? Because 4 of these cancel 4 of these, right? What's 3 of these cancel 3 of these, right? How many left? On the top or on the bottom? Good. And anything to the 0 power is? 1. Okay, so let's do it. Okay, I don't know who's calling me, but it's 206 number. I'll call back another day. I'm teaching, right? No phones, right? So first of all, these whole numbers make a 6. You okay with the 6? And 4 of these cancel 4 of these, so I get an x to the 3rd on the top.
Hold up, I do the 6.
24 divided by 4.
Oh.
I'm just doing whole numbers. Okay, so then 4 of these cancel 4 of these, right? 3 of these cancel 3 of these. Y to the 3rd on the bottom because there's 6 on the bottom, 3 on the top. And that right there, right?
But for the 6, yep. How did you get the 3 from 6?
Okay, so let's just do it here. Here's my 6. You see it? Boom. And now let's look at the x's. X3. So just look at the x's. 4 of these, 4 of these, 3 left over. See, so 4 of these, cancel 4 of these. How many left over?
So when you divide exponents, you take exponents.
Yes, I subtract exponent. Perfect. And then also look, 3 of these, take away 3 of these. How many left over? On the bottom, because there's more to start with on the bottom. Right? And then I can put it to the 1 power, or just to the 1, okay? You guys never learned this last year, huh? Wow. Okay, and so I don't really need the 1, but I'll put it there. So how about a 6x to the 3rd over y to the 3rd, okay? All right, now, negative exponents. When you see a negative exponent, oh, by the way, here, I'm going to write this. Elsa, I'm sorry, subtract exponents, because that's what you said, isn't it? You said take away, same thing as subtract, right? So when you divide, you subtract exponents. When you multiply, you add exponents. In an exponent to the exponent, we multiply exponents, okay? All right, now, number 5. When you see negative exponents, think fraction. Okay, you see negative exponents, write a fraction bar. When you see a negative exponent, just write a fraction bar. If it's on top, to make it a positive exponent, bring it down. Okay? That's all you do. So bring it down. That's all you do. Okay? So I'm going to bring down 2 things. I'm going to bring down the x to the negative 3 comes down as an x to the positive 3. The z to the negative 1 comes down as a z to the positive 1. Okay? Now the 4y cubed just stays where they are because they're not negative. Don't move them unless they're negative. Okay, example 6. When you see a negative exponent, think fraction. My 4 to the negative 2 comes down. I gotta switch them both. My x5 comes down, my x5 comes down, my x4 comes up. So I moved them both. My y's are just the way they are. My z5 comes up. I still have this. I still have this. I still have my y3, y3. Okay, let me show you what I have so you can see it. Okay, let me show you what I got. Make sure you got. So, all I did, move this one up. I moved x negative 5 down. I moved 4 to the negative 2 down. I moved z negative 5 up. And everything else I left where they were because they were not at negative. Okay, everything else stays right there. Okay, so 2 squared stayed down, y3 stayed down, this y3 stayed up, and the z to 0 I'm just going to make into 1. Okay, how am I doing? I just move. Okay. Now, let's see what I got. Let's see if I can fold right off the bat. Bailey, see this? Well, that's what you were asking, right? You agree with that? y3 over y3? So I'm going to have a 4 times 16. Where did I get the 4 times 16? 4 times 16. Where did that come from?
2 over 2 and 4 over 2.
Right? 4 and 16, right? Okay. Elsie, you ready? 4 of these cancel 4 of these, right? 4 of these cancel 4 of these. How many left over? Top or bottom? Where's the remainder? I got 4 of them here, 5 of them there. The remainder would have to be on the bottom because there's 4 of these. We cancel 4 of these and leave 1 left over on the bottom, right? It's really not that hard, is it? Okay, so then x on the bottom because I canceled 4 of these for 4 of these. Z to the 5th, and I don't see anything there, and times number 1. And so finally, I'm going to finish this. 1, I don't need the 1, but there it is, z to the 5th over 64x. All right. I've got a practice sheet for you, okay? Yes, we do have homework.